Lesson 1, Simplifying Radicals. A radical is a symbol that represents a particular root of a number. Here is an example of 4 basic square roots. For our first example, we have the square root of 9. When we think about simplifying square roots, we must think about two factors that will multiply to that number and focusing on making a pair out of those numbers. For example, 3 times 3 multiplies to 9. Now that we have that, we need to make a pair. 3 and 3 make a pair, which later comes out to be just one set of 3. That is our answer. The square root of 9 is 3. On our third example, the cube root of 24, we need a pair of 3 because it is cubed and not squared. Cubed means 3, so that means that we need 3 sets of a number to make a pair. To simplify the cube root of 24, we can do 2 times 2 times 2 times 3. We have 3 sets of 2, which can become a pair. So one of the numbers to our answer is going to be 2. Notice how we still have the 3 left over. What we do with that 3 is that since the 3 doesn't have 2 other 3's to make.
Lesson 2. Radical operations. We have to start by simplifying each term. So in this case, we would start with 12. The highest perfect square that 12 can be divided by is 4. So 4 times 3. The highest perfect square that 32 can be divided by is 16. So 16 times 2. Don't forget to add the parentheses. Then the highest perfect square that 72 can be divided by is 36. 36 times 2. Okay, oops. Okay, now we need to simplify the square roots. 9. Square root of 4 is 2. Okay. Square root of 16 is 4. And square root of 36 is 6. Okay, so after this, you may wonder why we have parentheses here. That's because we need to multiply these together. So 18 square root of 3. Then we combine like terms for this one. So 4 plus negative 6 is negative 2. And since these are the same numbers, we just put them together and it's 2. That's the answer.
Lesson 3, Converting Radicals to Rational Exponents. So we have to evaluate 125 to the power of 2 over 3. So we rewrite the whole question into a square root formula. So we would place the 125 in the middle, and with the 2 and the 3 would simply switch the places. So the 3 would go up in the front while 2 would go next to the 125. Then you just multiply 125 to the power of 2, which gives you 15,625. And then with that, you can break up the rancid into a product of the known factor, which gives you 25, or you can break it down to 25 times 25 times 25 and break that rancid up into a product of the known factors, which would also give you 25. This is the second equation. Lesson 4, Complex Imaginary Numbers. The original equation was created by Leonard Eulers when he used I as a placeholder for the square root of 1 in an equation. his equation actually provides a way to talk about complex exponents. And as you can see at the bottom, it shows the value for the imaginary numbers, such as I to the place of 0, or just I, it's equal to 1. I to the place of 1 is equal to I to the point of 2 is negative 1. You need to save this image or write it down and try to memorize at least up to 10 or 9. So we can use it in this next few equations. So equation 1, where it says 2I, and then in the middle it says 3I. So to figure out this equation, we would do, just 2 times 3, which would equal to 6. And then you would do I times I, which would equal to I to the power of 2, which equals negative 1. And then you simply just multiply 6 to the power 6 times negative 1, which equals negative 6. So that's the answer to equation number 1. Then to equation number 2. To figure out this equation, you have to do negative 4 times 5, which equals to negative 20. We then add the I into the negative 20 because of the negative 4I. And then we do negative 4 times negative 6, which equals 24. Then we do I times I, which equals to I to the power of 2, which, as we know from the chart and the question before, equals to negative 1. So we do 24 times negative 1, which equals to 24. So we just put the answers that we figure out together. So the final answer is negative 24 minus 20I, or negative 24 and negative 20I.